When the guns fell silent in 1945 and Japan formally surrendered on the deck of the USS Missouri in Tokyo Bay, the United States Navy faced a problem unlike any other military had ever confronted in the entire history of naval warfare. Across dozens of anchorages stretching from Norfolk, Virginia to San Diego, California, from the frozen waters near Iceland to the tropical harbors of the Philippine Islands and beyond, a staggering fleet of warships sat idle and redundant. Among these vessels floated 563 destroyer escorts, nearly identical warships measuring 306 feet from stem to stern, displacing approximately 1,400 tons each. These nimble warships, once the hunters of German U-boats prowling the Atlantic convoy routes and protectors of invasion fleets during the assaults on North Africa, Sicily, Normandy, Iwo Jima, and Okinawa, had suddenly become an enormous economic burden that the American government simply could not afford to maintain in its current state. The physical scale of this problem is genuinely difficult to comprehend. 563 warships, each capable of independent deployment, each requiring crew of nearly 200 officers and men, each demanding supplies, fuel, spare parts, maintenance, and operational support. These were not small craft or minor patrol vessels. These were legitimate warships of modern design, bristling with anti-aircraft weapons and sophisticated anti-submarine equipment, capable of crossing oceans under their own power and remaining at sea for weeks or months at a time. Every single one of them had been painstakingly constructed by American workers in American shipyards during the desperate years of the war. They represented the absolute cutting edge of warship design and construction efficiency, optimized for rapid mass production without sacrificing fundamental capability and seaworthiness. The scope of this surplus was genuinely unprecedented in naval history. The destroyer escort program, conceived as America's answer to the devastating U-boat crisis of 1942 and 1943, when German submarines were sinking merchant vessels faster than American shipyards could possibly replace them, had proven itself to be one of the most successful warship construction efforts ever undertaken by any nation in history. Working around the clock in multiple shifts, American shipyards had delivered destroyer escorts faster than any other warship type. Some vessels moved from keel laying to final commissioning in less than 6 months, an extraordinary achievement that reflected the ingenuity of American industrial organization and the dedication of the American worker. The speed of construction was possible because these ships were deliberately designed to be simpler and cheaper than full-size destroyers, which required complex machinery that was beyond the capability of smaller shipyards to construct. Rather than competing with larger warships for the scarce steam turbines needed for faster vessels, destroyer escorts relied on diesel-electric or turbo-electric propulsion systems that were more readily available and could be produced by a wider variety of manufacturers. They could be mass-produced using prefabrication techniques that made them accessible to small shipyards that couldn't possibly handle battleship or cruiser construction. The results had been nothing short of remarkable. By the end of the war, these ships had become fixtures of the American naval arsenal, and they had proven their worth repeatedly throughout years of continuous operation. During the war years, destroyer escorts had participated in convoy escort duty across both the Atlantic and Pacific, protecting merchant vessels from submarine attack and enabling critical supply shipments to reach beleaguered Allied forces. They had sunk 67 German U-boats and numerous Japanese submarines, contributing directly to the eventual defeat of the Axis powers. They had supported amphibious landings by providing gunfire support against enemy defensive positions and protecting invasion beaches from counterattack. They had earned battle stars and commendations for their crews, recognition of their crucial contributions to victory. Some had been heavily damaged in combat and painstakingly repaired to fight again. Others had gone through the entire war without a single scratch, proving the robustness of their construction and design. Every one of these 563 destroyer escorts represented an enormous financial and material investment. The Navy's own calculations showed that each ship had cost approximately $6 million to construct, an astronomical sum for $1945, equivalent to roughly $120 million in modern currency when adjusted for inflation. The combined investment across all these vessels totaled over $3 billion in direct construction costs alone, representing wealth comparable to the entire industrial output of entire nations for an entire year. Yet that financial reality created an economic paradox that haunted naval planners in those first weeks following Japan's surrender. These were modern warships, less than 3 years old on average, with potentially decades of service life remaining if properly maintained. They weren't worn-out relics from an earlier era that had been superseded by new designs. They were capable platforms that had proven themselves repeatedly in actual combat situations. Many had earned battle stars and other commendations for their crews for extraordinary service under fire. Some had participated in major amphibious assaults that fundamentally changed the course of the war in the Pacific theater. Others had joined in the hunt for German U-boats in the Atlantic, directly contributing to the destruction of enemy underwater forces and the survival of merchant convoys. The Navy would eventually estimate that maintaining this enormous fleet in active reserve would cost approximately $850 million annually, an impossible figure given that Congress had begun slashing naval budgets by as much as 75% in response to overwhelming public demand for rapid demobilization and a return to normal economic life. The wartime economy that had mobilized the entire nation for total war evaporated almost overnight as industries shifted from military to civilian production. Shipyards that had operated at maximum capacity, working night and day to produce warships by the hundreds, now needed to return to commercial work or close entirely. The political pressure for demobilization was overwhelming. American soldiers and sailors wanted to come home and resume their civilian lives. Veterans organizations, families, and the American public wanted an end to wartime sacrifice and a rapid return to the normal peacetime life that American citizens had been denied for nearly 4 years. In this environment, defending a massive fleet of destroyer escorts that served no immediately obvious purpose became politically untenable. Each destroyer escort required a crew of 186 officers and men to operate effectively during peacetime. 186 families with their own economic needs, their own career aspirations, and their own desire to return to civilian life and productive employment in the growing American economy. Multiplied across 563 ships that represented over 100,000 military personnel who would need to be either kept in the Navy indefinitely or released for civilian employment. Veterans wanted civilian jobs, families wanted their sons and husbands home, and the public wanted the government to stop spending enormous sums on military equipment when there were pressing civilian needs to be addressed: housing shortages, educational needs, and industrial conversion. The Navy faced a choice that would define American naval power for the next quarter century: which destroyer escorts truly deserved preservation for future use, which would face the scrapyard and recycling, and whether any meaningful portion of this enormous resource could be retained in some form of active readiness without bankrupting the national defense budget. This decision couldn't be made lightly, because the late 1945 international environment was already showing ominous signs that would lead to the Cold War. The Soviet Union, which had contributed so much to defeating Germany and Japan, was beginning to reveal its true colors as a rival rather than as a genuine ally. Soviet submarines, including captured German-type Wang boats with advanced technology, were being integrated into the Red Navy for study and eventual operational use. American intelligence agencies were warning that the Soviets had begun a massive submarine construction effort that would eventually threaten American naval dominance in the world's oceans. The threat of a Cold War was becoming increasingly apparent to those in the Pentagon who studied such matters. Section 2. The Navy's Strategic Calculation and Initial Disposal Plan. By December 1945, having completed their initial assessment of the situation, the Navy had formulated its official plan for dealing with this massive surplus of destroyer escorts. The decision represented a careful balancing act between opposing forces, strategic necessity on one side, and harsh economic reality on the other. Approximately 100 destroyer escorts would remain in active commission, primarily distributed across the Atlantic and Pacific fleets, where they would participate in peacetime operations, conduct training exercises, patrol foreign waters, show the American flag in strategic ports, and maintain operational expertise among naval personnel. Another 200 vessels would enter the reserve fleet to be preserved and maintained in such condition that they could be quickly reactivated if the international situation suddenly deteriorated or war erupted. The remaining 263 ships faced disposal through scrapping, sale to allied nations, or conversion to other specialized purposes. This decision reflected both sides of the calculation perfectly. The Navy recognized that future conflicts might require convoy escorts, and that maintaining some destroyer escort capability made strategic sense given the emerging Soviet threat and the known expansion of Soviet submarine construction programs. But keeping all 563 ships fully operational was financially impossible given congressional budget constraints. The reserve fleet concept represented a reasonable compromise that preserved strategic capability while reducing immediate operating costs. These ships would be preserved in a state called mothball readiness, meaning they would receive enough maintenance and preservation to remain operable, but would sit empty and unmanned, consuming far fewer resources than fully active-duty vessels with complete crews aboard. The destroyer escort program itself had consisted of 6 distinct classes, each with different propulsion systems and armament configurations. The Escorts class, the earliest, numbered 97 ships and relied on diesel-electric propulsion. The much larger Buckley class contained 154 examples using turboelectric drive with improved anti-submarine armament, designed specifically for hunting submarines. The Cannon class numbered only 72 ships and returned to diesel-electric propulsion, but with different reduction gearing. The Edsel class comprised 85 vessels with direct-drive diesel engines that proved to be remarkably reliable throughout the war years. The Ruddero class had 72 ships and represented an improved Buckley design, with enhanced armament. Finally, the John C. Butler class, the most advanced of the group, numbered 83 ships and featured steam turbine propulsion that made them notably faster than their predecessors. This variety complicated preservation decisions dramatically because maintaining 6 different types of machinery and spare parts inventories would prove enormously expensive. The Navy prioritized the newest and most capable examples for active service retention. The John C. Butler class and later Ruddero class vessels, which offered the best performance and most modern systems, received preference for remaining in commission. By mid-1946, approximately 87 destroyer escorts remained in active American naval service, primarily operating with Atlantic Fleet anti-submarine warfare squadrons, conducting regular patrols, training exercises, and diplomatic missions, showing the American flag in foreign ports throughout the Atlantic and Mediterranean. Section 3. The Mothball Fleet, Preservation Science and Naval Strategy. Between 1946 and 1948, the Navy implemented one of the most ambitious ship preservation programs in the entire history of naval operations. 203 destroyer escorts were selected for the reserve fleet and systematically prepared for long-term storage at facilities strategically located across the United States. These preservation facilities became centers of specialized naval expertise, and the process of preparing ships for long-term storage developed into a genuine science based on lessons learned from earlier preservation efforts. Green Cove Springs, Florida, established itself as a major Atlantic Reserve Fleet location, eventually holding several hundred vessels of various types. Norfolk, Virginia, and Charleston, South Carolina hosted Atlantic Fleet reserves and facilities that had been used for ship repair and maintenance. Orange, Texas, with its abundant fresh water supply on the Sabine River, became the Texas group of the Atlantic Reserve Fleet and eventually housed 250 mothballed ships of various classes. The freshwater supply was crucial because it prevented the formation of salt crystalline deposits that could accelerate corrosion on exposed metal surfaces. San Diego, California hosted the Pacific Reserve Fleet counterpart, where the mild climate and deep-water harbors made for ideal preservation locations. The preservation process was not simply a matter of pulling ships into a harbor and leaving them to rust away into oblivion. It was technically sophisticated and remarkably thorough, reflecting decades of accumulated naval experience, maintaining expensive equipment in long-term storage, and lessons learned from the temporary repair and preservation methods used during the war itself. The Navy understood that improper preservation could result in the complete deterioration of machinery, electronics, and hull structure, rendering these ships worthless for reactivation within just a few years. Decades of metal would corrode from exposure to salt spray and moisture, Engines would become seized with rust and corrosion. Boilers would develop internal corrosion and scaling. Electrical systems would deteriorate beyond salvaging, and hull plating would develop leaks and weaknesses that would require extensive repairs. The preservation protocol began with complete draining, cleaning, and protective coating of all machinery in the ship. Every drop of fuel oil, hydraulic fluid, lubricating oil, and other liquid had to be carefully removed and replaced with special preservative compounds specifically designed to prevent corrosion from the inside out. Engine cylinders were filled with nitrogen gas to prevent moisture and oxygen from promoting rust formation on internal cylinder walls. Boilers received special treatment to ensure that the internal surfaces remained protected during years of storage without steam. Pressures and circulation. They were filled with special deoxygenated water and sealed completely to prevent air circulation and corrosion. All electronics were carefully removed from the vessels and stored in climate-controlled warehouses ashore, where they would remain protected from salt spray, moisture, and the destructive effects of the harsh marine environment. This was a monumental task because destroyer escorts carried sophisticated radar systems, sonar equipment, fire control systems, and communications gear that cost thousands of dollars each and represented the most advanced technology available at that time. Guns were preserved with special greases and covered with protective cosmoline, a thick waxy substance that had been used to preserve military equipment since World War I. Hedgehog anti-submarine mortars, which were particularly sophisticated for the era, received special attention because they were complex mechanical devices that could be damaged by corrosion. Hulls were meticulously cleaned, scraped of any barnacles or marine growth, painted with specialized anti-corrosion coatings, and then regularly inspected to ensure no breaches or structural problems were developing. The Navy established a goal of maintaining these ships in such condition that reactivation could be accomplished within 90 days if necessary. This was an aggressive timeline but considered achievable if the preservation effort was thorough. This meant that water systems, fuel systems, electrical systems, and propulsion machinery all had to be preserved, not just to prevent total deterioration, but to remain actually functional and capable of operation. The sophistication of the mothball fleet operation extended to environmental control systems that seem almost impossibly advanced for the 1940s. Some of the more valuable ships had internal flooding alarms installed, initially using styrofoam balls with battery-operated buzzers that would float and tip over if a compartment began to flood, making an audible alarm that could be heard on nearby ships. Later, the Navy developed electronic scoreboard systems with red and green traffic signals hung on nearby ships in a berthing group, creating a visual monitoring system. Each colored light represented the status of a particular compartment on a mothballed vessel, allowing maintenance personnel to instantly identify problems without boarding individual ships. If a light went red, maintenance crews knew which compartment needed immediate attention. This system was ingenious and allowed one small maintenance team to monitor dozens of ships simultaneously. Deck drainage systems received special attention because standing water was one of the greatest enemies of long-term preservation, causing corrosion and structural damage. Any depression or dent in the main deck that might collect rainwater was either leveled or coated with epoxy. Some features that naturally collected standing water had small holes drilled in their bottoms to permit drainage. On some escort carrier conversions that had flight decks, the Navy even intentionally created a 1-degree list to encourage rainwater runoff away from critical areas of the vessel. This painstaking preservation infrastructure required trained personnel, specialized equipment, and constant maintenance. While the direct operating costs of a mothballed ship were dramatically lower than an active vessel, no fuel consumption, no crew wages, minimal operational expenses. They were not zero. Regular inspections had to occur, typically monthly or quarterly, to check for signs of deterioration or developing problems. Preservation materials had to be reapplied periodically as the protective coatings gradually degraded from exposure. Environmental control systems had to be monitored continuously to ensure they were functioning properly. Section 4. Scrapping and foreign military transfers. The largest single disposal method for surplus. Destroyer escorts was scrapping. Between 1946 and 1948, 147 destroyer escorts were sold to commercial shipbreakers and systematically dismantled piece by piece. Most went to major yards in New Jersey, particularly around the Newark area, in Texas and in California, where highly specialized workers used cutting torches, explosive charges, and heavy equipment to reduce these complex warships to their component materials. The dismantling process began with careful draining of all remaining fluids. Hazardous materials were carefully removed and safely disposed of according to procedures of the time. Then the cutting work began, systematically reducing the ship from bow to stern into sections that could be further processed. The steel was particularly valuable in the immediate post-war period when American industry was rapidly retooling for peaceful production. Civilian construction was resuming after years of military focus, and builders needed large quantities of steel for apartment buildings, office buildings, bridges, and infrastructure projects across America. The demand for scrap steel was enormous, and destroyer escort steel could be melted and reformed into new products. Each destroyer escort yielded approximately 800 tons of scrap steel, 15 tons of valuable copper from electrical systems and wiring, and smaller quantities of brass, aluminum, and other specialty metals that could be recycled into manufacturing. The Foreign Military Aid Program proved to be a far more strategic use of destroyer escort surplus. Between 1946 and 1952, 79 American destroyer escorts were transferred to Allied and friendly foreign navies through the Mutual Defense Assistance Program, which was established specifically to strengthen NATO and other anti-communist allies during the emerging Cold War. This program served multiple purposes simultaneously. It disposed of surplus American vessels that the Navy no longer needed for its own purposes. It strengthened the naval capabilities of Allied nations, whose fleets had been damaged or depleted by years of warfare against the Axis powers. It maintained American military influence in critical regions of the world during the early Cold War period. It created opportunities for American technical teams to train foreign crews in American ship operations and maintenance, thereby spreading American naval doctrine and practices around the globe. France received 13 destroyer escorts under the Mutual Defense Assistance Program, commissioning them between 1950 and 1952 to help rebuild its navy after devastating wartime losses that had seen major portions of the French fleet sunk or damaged. The Netherlands acquired 8 vessels, redesignating them as frigates and using them for colonial defense in the East Indies, where Dutch forces were struggling to maintain control as independence movements challenged colonial rule. Brazil obtained 7 destroyer escorts, which became the backbone of its anti-submarine force, and made Brazil a significant naval power in South America with genuine ocean-going capability. Italy received 4 vessels for its Mediterranean operations. Greece took 6, including the famous USS Slater, which would eventually be returned to the United States decades later as a museum ship. Smaller numbers of destroyer escorts went to the Republic of China, Uruguay, Mexico, and other nations that had either been American allies during the war or had become important Cold War allies. Each transfer was carefully managed with American technical teams training foreign crews and establishing maintenance procedures for long-term sustainability. The continuing reliability of these foreign fleets depended on American spare parts, American training, and ongoing American technical support. In a sense, these destroyer escorts continued serving American strategic interests long after leaving the American flag, dispersing American naval technology and doctrine throughout the post-war world and binding foreign navies to American support networks. Section 5. The Korean War and Unexpected Reactivations. The outbreak of the Korean War in June 1950 dramatically reversed the Navy's entire disposal strategy that had been in place for the previous 5 years. When North Korean forces crossed the 38th parallel and invaded South Korea in a brazen military aggression, suddenly the geopolitical situation changed completely, and the American military needed every available escort vessel for convoy protection, amphibious support, and blockade duties around the Korean peninsula. All those carefully mothballed destroyer escorts, preserved with such meticulous care in Green Cove Springs, Florida, and the other reserve fleet facilities scattered around the United States, suddenly became valuable assets that were desperately needed for immediate deployment. Between July 1950 and December 1951, the Navy recommissioned 39 destroyer escorts from the reserve fleet as part of the emergency mobilization for Korea. Some of these ships had been in storage for merely 2 years, while others had sat idle for nearly 5 years, raising serious questions about whether the preservation effort had been successful. Yet the mothballing process, for all its complexity and expense, proved its worth in this emergency situation. The recommissioning timeline demonstrated the wisdom of the preservation effort. Most of these ships were ready for sea within the planned 90-day timeframe, a remarkable achievement given how long they had been inactive. The machinery was actually functional because it had been preserved rather than simply stored and forgotten. The hulls remained sound because they had been protected from the marine environment and constant exposure to salt spray. The process of reactivating a mothballed destroyer escort involved meticulous work by naval engineers and highly trained technicians who understood the intricacies of these complex vessels. Fresh crews arrived at the reserve fleet sites and began the process of undoing the preservation work that had kept the ships in storage. Electronics were removed from warehouse storage and carefully reinstalled in their original locations. Boilers were refilled with deoxygenated water and brought slowly online through careful heating to avoid thermal shock to the metal. Engines were carefully started and run through their paces to ensure they would operate reliably under load. Fuel systems were cleaned and tested. Weapon systems were inspected and tested to ensure they would function reliably in combat. The recommissioned destroyer escorts served primarily in the Pacific Theater, escorting supply convoys to Korea, providing gunfire support during amphibious operations, and conducting coastal patrols around the Korean peninsula searching for enemy activity. These ships found themselves engaged in actual combat operations for the first time since World War II, using their guns against North Korean positions and providing naval gunfire support to ground forces requesting their firepower. Some ships were damaged by enemy action and had to be repaired at distant shipyards. Others performed flawlessly throughout their service in Korean waters. Section 6. Modernization, Conversions, and Final Years of Service. The post-Korea period saw continued attrition of the destroyer escort fleet through a combination of scrapping, foreign transfers, and specialized conversions that attempted to extend their useful service life. Between 1953 and 1957, an additional 73 destroyer escorts were sold for scrap as the Navy reduced its force structure and accelerated decommissioning of older vessels. The reserve fleet shrank as well, with some vessels deteriorating beyond economical repair after years of storage in preservation status. By 1960, only 62 destroyer escorts remained in active American naval service. Even these remaining active ships faced conversion and modernization programs. The most significant conversion created radar picket escorts designated as DERs, which received enhanced radar systems and communication equipment for early warning duties. 26 destroyer escorts underwent this conversion between 1949 and 1952, emerging with distinctive tall radar masts and expanded operations centers. These DER conversions reflected the fundamental shift in naval priorities as the threat evolved from submarines to aircraft and guided missiles. The Soviet submarine threat of the late 1958 prompted one final major modernization effort. The Navy selected 35 destroyer escorts for conversion under the Fleet Rehabilitation and Modernization Program, known universally as FRAM. These vessels received updated sonar systems, improved anti-submarine weapons, including the new ASROC rocket system, and enhanced communications equipment. By extending the service life of these destroyer escorts for an additional 8 to 10 years at roughly half the cost of constructing entirely new ships, FRAM preserved fleet readiness during budget constraints in the 1960s. The final years of destroyer escort service stretched into the mid-1970s. The last vessels in American service were decommissioned between 1972 and 1974. Foreign navies kept destroyer escorts operational considerably longer, with some Taiwanese vessels remaining in commission until 1999. Section 7. Preservation, Legacy, and Historical Conclusions. Preservation of destroyer escorts for museum display proved remarkably limited given their numbers and historical significance. Of the original 563 vessels, constructed only 2 survive today. The USS Slater, a Cannon-class destroyer escort, is preserved in Albany, New York after extraordinary service with the Greek Navy. The ship was reacquired by American preservationists in 1993 and meticulously restored to represent a typical destroyer escort as it appeared at the end of World War II. The technological legacy of the destroyer escort program influenced American naval design for decades. The destroyer escort represents a unique moment in American military history when unprecedented industrial capacity met urgent military necessity, producing thousands of efficient, effective warships in incredibly short time. That their disappearance was nearly complete, that a 99% loss rate means a single surviving example represents the entire program, testifies to the disposable nature of military equipment in the modern age. The USS Slater, floating in the Hudson River in Albany, represents not just the memory of 562 other ships, but an entire era of American naval dominance that has largely faded from public consciousness. The destroyer escorts that won the Battle of the Atlantic and supported operations across the Pacific have become ghosts in the historical record. Walking across her decks, visitors can experience the vessel much as crews did decades ago. If you found this detailed documentary about the destroyer escorts interesting, I'd encourage you to hit that like button and subscribe for more in-depth explorations about what happened to military equipment, ships, and weapons after wars ended. Thank you for watching.